First, I really want to thank you all for having me. I'm excited to be here. Um, I, it's awesome that there's this blockchain security conference going on, and you guys are doing great work with this. So, um, what we're going to be talking about today is talking to your users about cryptocurrency security. I think this is an important topic that maybe gets missed sometimes. And, I want to really explain from sort of a tech educator perspective why it's so important to talk to your users about security and give you some new ideas about how to think about that. A little background on me. I'm a software engineer at Microsoft in Pittsburgh. So my day job, I don't work on cryptocurrencies. I'm sort of a systems and back-end developer. And of course, the work that I do with Chained is not representative of my employer. And I am a tech educator at my personal project that I call Chained. And my mission is really just to build free and open source technical education. So I'm trying to help people around the world from all walks of life understand this really interesting and empowering technology. Especially cryptocurrencies, blockchains, and digital security topics, even like, passwords and two-factor auth, and really how to keep yourself safe online, especially interacting with this new cryptocurrency space. Before I get into what we're going to talk about specifically today, I'm going to talk about, a reminder of what the core of crypto ownership is. And that's private keys. So we call a cryptocurrency private key store a wallet. That's the industry terminology that we use. And it's absolutely critical that wallets with our private keys in them are both securely generated. So the keys themselves are actually generated in a secure manner and securely stored for the long term. Users, these keys are what gives you full and utter access to spend and transfer cryptocurrency, all of your money. There's differing what I would describe as classes of wallets, all with differing threats that you have to understand and address when we're talking about security. So what are we actually going to talk about today? I'm really going to give kind of a broad overview of understanding wallets and the threats that specific classes of wallets face, and some of the common vulnerabilities and attack vectors that are out there. A lot of this that you're going to hear from me today is probably not going to be news to you as technical and security professionals, right? I'm not here to share new specific vulnerabilities or issues. What I really want to talk about is new perspectives on how to understand wallet security and present this to your users. So I'm really here to talk about security education, because I think we, as the technical builders in the space, have a duty to educate our users about security and how to keep themselves safe when interacting with this technology. Just like if you're a web application owner, you should enforce strong passwords and two-factor authentication and those sorts of things. I think this is a topic that sometimes gets glanced over in the space because, it is sort of this very young technology. And I think some of us that are technical folks have a mentality that users should just get down to it and understand it and be their own bank. And if they screw up, woe on them. But, with the great power of being your own bank comes a great responsibility to understand your own safety and security. And so I really want to focus on presenting security information to people from differing backgrounds. So what I'm going to discuss is a couple broad classes of wallets and a sort of broad security overview of these different types of wallets. We're going to talk about some common cryptocurrency threats, and we're going to end with some security bullet points that you can give to your users, give to your clients, give to anybody that's interacting with this space and in your applications that you're building. So in terms of wallet classes or wallet categories, whatever sort of terminology you would like to use, perhaps even wallet types, there's kind of a sliding scale from generally the most secure types of wallets to generally the least secure. Offline wallets are definitely the top when it comes to long-term storage security and safety. Offline wallets being things like hardware wallets primarily, are sort of the gold standard and the modern standard, but this also could include offline generated single key pairs. I'm going to get into a little bit later why single key pair is kind of fallen out of favor. But generally when we're talking about offline wallets and cold storage, we're talking about hardware wallets. The next class of wallets, and I should say the next broad class of wallets, is online storage. So wallets that are stored on a device that is generally connected to a network. At the top of this list in terms of security, and this may actually seem surprising, is really mobile wallets. So wallets that are installed and run on iOS or Android. And the reason that professionals like Andreas Antonopoulos and some security professionals and I say mobile wallets are preferable in the online space is because the operating system on your mobile device is going to be locked down a bit more than the operating system that is on your desktop, for example. And we'll get into that a little bit more. The next broad class is online desktop wallets. So this is something like a Coinobi wallet or Electrum or Electron Cash that you install on a desktop device like a laptop, computer desktop, etc. And really the least secure and I would say most discouraged for non-custodial, so exchange type of service is online web wallets. So this is something like the blockchain.com wallet is by far the most popular example. And there's quite a few reasons why this is generally not so preferred. Now, there's sort of a special case, and it's a broad and important special case, and that's exchanges, custodial storage, where the user is not given any private keys to store and own their own cryptocurrency, but it's those private keys for that cryptocurrency are stored with a custodian. So prominent examples would be Coinbase, Binance, Gemini. It's kind of a special case for a couple of reasons, and that's because we're not talking about the users being responsible for their own money. We're talking about a custodian, and then we have to talk about the security and hygiene of how the user logs into that custodian, along with the custodian storage practices themselves. Broadly speaking, offline storage is going to be better and more secure for the long term than online storage. So if you're storing large amounts of money, when you're talking about savings and especially money that you're not going to interact with for some period of time, offline cold storage is going to be better than online storage. Specialized hardware is better than general purpose. And what I mean by this is something like a hardware wallet. So a device that has specialized cryptographic firmware loaded onto it, I think is in general going to be better in terms of long-term security of those private keys than a general purpose network device like a phone or a laptop. In general, in the cryptocurrency space, we really do prefer self-custody to an exchange. The whole sort of idea with Bitcoin, with Litecoin, with Bitcoin Cash or Ethereum is you get to be your own bank. So you get to hold your own keys, and that means you are truly holding ownership over your own money. I say this with a caveat. The user needs to be prepared for this, right? Most of us are kind of used to custodial money, right? A lot of us probably have bank accounts. Maybe you don't. Maybe you live in more of a cash-based sort of society where you're at. Some folks in the world don't have access to traditional banking. But in general, we're sort of used to credit cards. We're used to debit cards, bank accounts, and custody. We're used to kind of having somebody that can bail us out if we get hacked, right? If my credit card gets hacked, my number gets out there, I'm not responsible for those charges. It doesn't work that way with Bitcoin. If I make a mistake and lose money, there is no one there to rescue me. And so, there should be kind of an expectation that users are prepared for this before they move to self-custody. This is perhaps a controversial opinion in the crypto space, but I think if you're talking about an introductory amount of money, you're just getting your feet wet in cryptocurrency for the first time, and you are not a technical person, it's probably okay to keep a little bit of your money on a reputable exchange, because you may be tuned into password security and two-factor security more than you are private key storage for the time being. This will give you some time to learn. So overall, in general, the amount of money that we're talking about is going to dictate the level of security needed, right? The amount of security that you need for your spending money is different than the amount of security you need for your life savings of your Bitcoin. So let's talk offline wallets. I think users should always be highly encouraged to use hardware wallets. These are great and very well audited devices. So all key generation and storage is done completely offline on specialized hardware. Examples of this include the Trezor, the Ledger, KeepKey, and there's some other ones out there, but those are kind of the most well-known and most well-vetted. This is done on specialized hardware that has firmware that is specifically for Bitcoin cryptography, right? These are microcontroller devices, and they're programmed to do one single thing: Bitcoin cryptography, Ethereum cryptography. So what this does in terms of security is it greatly lowers the attack surface for key theft. No one can watch the key generation or signatures in some way that might cause a problem for key leakage. Someone can't phone home with stolen keys like they could on your laptop if there's some kind of malware. And these devices generally don't run general purpose malware. Their firmware is explicitly designed that when you plug that device into a computer, the only data that it allows you to send to itself is the information that you would need to generate a signature for a transaction to send money, right? It doesn't have this ability to run a very general purpose malware like a laptop does. So I actually made a sort of demo proof of concept of my very own hardware wallet called MicroBitAdder, UBitAdder. This was a demo proof of concept that currently only does single key pairs, but it was kind of a demonstration that I've talked about at I had a chance to talk about it at DEF CON and some other talks. This is something that can be done with open hardware, open software, and it's a really neat and interesting way to generate keys and store keys. My particular demo only generates keys and presents them to the user in an encoded format, so you could write them down and store it offline. General availability hardware devices like the KeepKey or Trezor, they give you a seed, and then they also store the keys encrypted and can do transaction signatures and that sort of thing. Now, for online use, we should encourage mobile applications over desktop or web wallets, I think. So this is for your spending money. Mobile devices have a more locked down operating system. Now, I'm not in any way saying that this is foolproof. I mean, of course, there could be a lot of issues with something like a mobile device, and they do have vulnerabilities. But in general, an Android device or an iOS device has a more lockdown system, more safeguards in place. Most users go through app stores, right? So, most users, if they're careful or not, it's not as easy to download a malicious application that might try to get at your keys or ask you to sign a false transaction. So I like to use Bitcoin.com, for example, for Bitcoin Cash and Bitcoin. Coinomi is another one that I use. I don't, have any relationship with these companies. They're just ones that I've used that I've found to be usable and, have some decent security practices. So in general, when we're talking about you're spending cash, to pay your phone bill, to buy a book, to buy some jujitsu gear, things that I like to buy, right? You can use a mobile wallet for that purpose. Now, let's talk about online wallets for desktop. These can have some issues. And the primary issues with this sort of wallet is they present a very high attack surface. There's malware threats. So, there's issues with people accidentally downloading malware onto their laptop, which can cause all sorts of problems when you're interacting with cryptocurrencies. You could have key leakage or theft of your keys that somebody could find out how to get at unencrypted keys potentially and send them off to an attacker. You have phishing attacks. Now, this is not something that's necessarily prevented by using a mobile or hardware wallet, but if you're commonly interacting with a desktop wallet, phishing attacks are issues. I'm going to talk a little bit about that later in Let's Talk Threats. And of course, bad passwords and password reuse. There's a whole host of issues and a whole host of hacks that have happened for people that, they reused a password all over the place. That password got leaked and cracked as part of a password dump data set. And attackers used that email and password to log into their blockchain.com wallets, log into their email to verify and wipe them clean. These are real things that have happened, and they're very scary when you talk about online wallets and desktop wallets. It just provides a much broader surface for all kinds of different vulnerabilities. I'm certainly not giving a comprehensive list of issues, and I don't know a comprehensive list of potential issues. But in general, the difference between a web wallet and a hardware wallet is the online wallet has a lot broader class of vulnerabilities that can happen with it and cause issues for your users. And again, exchanges are a special case because you're not being your own bank when you use an exchange. You are holding keys yourself. So in that case, your security is only as good as two very important things. The first thing is your security is only as good as their security. And that's a very big target. So this is not something to, ignore or brush over, right? You really want to pick a good exchange if you are going to store money on an exchange. Like use a Coinbase, use a Binance, use an exchange that hires some of the best security experts in the world and takes their security really, really seriously over a small startup. And, I hate to say that because I think startups are great, right? But the security of the exchange itself is a really, really huge target. Now, the second very important target that falls on the users is your security is only as good as your password and two-factor hygiene. So if you're storing money on an exchange, you should absolutely make sure that you have a very long, strong passphrase that is unique to that website. And you should use app or hardware-based, like a YubiKey, two-factor authentication. SMS text message-based 2FA is not acceptable for this purpose. And we'll talk a little bit more about that as well. So let's get to the extra fun part. Let's talk threats, right? Let's talk some examples of threats that users are facing when it comes to their cryptocurrencies. Malware threats are a big one. And this primarily affects your desktop, web, and mobile. Because again, this is sort of the broadest target for attackers, right? To try and specifically attack a user's offline hardware wallet is a much bigger task than it is to create a very broad, malware attack that, you can potentially get to affect a lot of people. Address jacking, address swapping is one of these examples. I actually coded up a demo of this address swapping malware, and I call it Adderjack. So if you go to my YouTube channel, the ChainToots channel, and my GitHub, I have a very simple demo written in C#.net of an address swapping malware. You can see on the slides a static example of this. What happens with this class of malware is when somebody copies an address into their copy-paste buffer, so they Control-C or right-click and copy a Bitcoin address. If this malware is lurking on their system, it can detect the format of a Bitcoin address using a regular expression. And when it detects that address, it replaces the intended address that's in the copy-paste buffer with an attacker's address instead. So in this example, I tried to copy the address starting with 1BRL, and my little demo detected that a Bitcoin address was in the copy-paste buffer and replaced it with one fake don't send invalid. So this is a real threat that has happened to people. I've had people reach out to me via my project that lost money this way. Their coins, they copied an address, they pasted the address and didn't double, triple check it. And what they did is when they went to send that transaction, that money got sent off to an attacker's wallet instead. So, I have this educational demo that you can check out, but I'm sure there's, real samples of this out there as well. I mean, this is a real threat that's happened. And it's kind of scary if you think about it, right? A lot of us kind of blindly trust our copy paste buffer, but you shouldn't do that. You should really ensure that when you go to send money, you double, triple check your addresses. Fake wallet software is a big one. So the Electrum phishing attack is a primary example of this. Electrum had a whole issue with, there was sort of an injection attack that tricked users via one of their sort of updates, update notifications into installing a fake version of the Electrum software. And so when that fake software got installed, then when users would log into their wallet, it would steal their keys and send the money off to attackers. I'm not super well versed in that particular attack, but I know it caused kind of a big issue for a lot of users. And of course, there's sort of a whole class of malware that's theoretical and real, that's somebody could just steal your keys, right? If you have a desktop or mobile wallet and those keys aren't stored properly, maybe they're not properly encrypted with a strong passphrase, of course you're running a general purpose device. So someone could write malware that looks for wallet.dat, looks for the sort of signature of 12 to 24 seed words, even if you're putting your seed words somewhere unencrypted and use that to steal funds. Another very common threat, of course, is bad password and two-factor hygiene, right? This is something that doesn't just affect cryptocurrency, of course. This is something that affects all kinds of online accounts. Frankly, most people don't take their password security seriously enough. And this is something I always try to nag my friends and family about, is to use strong passphrases, use unique passphrases. Most people, unfortunately, reuse their passwords. So, Google and Facebook and Coinbase and Binance have good security over their password databases, surely. But the problem is if you reuse your password for those accounts on some, one-off Etsy website or something that doesn't have very good security, and that gets leaked in an attack, now attackers have your password. Right, with Hashcat and John the Ripper and all kind of modern password cracking tools, the passwords that most people use are fairly easy to crack and to find. And then attackers will use that email, use that password combination to try exchanges like Coinbase, to try web wallets like blockchain.info, and that can be used to completely wipe people out. It's a very scary and real class of attack. The other one that's important to talk about is SIM swapping. don't use SMS text message-based two-factor authentication for exchange accounts or for web wallets. Like, it just don't. People with high net worths that are involved in the crypto space have absolutely been targeted by this type of attack in the past. If attackers know that they have your phone number, if they can get your phone number and they know that you're on an exchange or something like that, they will try to call up AT&T or Verizon or Sprint and get the phone number transferred into their hands so they can reset access to the account using the SMS two-factor, as a reset or something like that. I know people in my network that have lost tons of cryptocurrency in that way. So instead, we should use the app-based, like TOTP is kind of the most common standard for that. It's a time-based one-time password. That's usually what you have when you use Microsoft Authenticator or Duo or Google Authenticator. Even better yet, get people to buy YubiKeys, right? A YubiKey hardware token is even better. And that's a lot better than what most people do, which is skip two-factor entirely. I think that two-factor is something that should be enforced, or just completely required for any kind of cryptocurrency-related web application or exchange, because protecting users is extremely important, and two-factor is very, very important for keeping them protected against password leaks and that sort of thing. Most people don't use long or higher entropy passphrases. I did a tutorial on this recently about password security, right? Length is, generally speaking, much, much more important than complexity. So we've been kind of taught that, if you have an 8-character password with a bunch of wingdings in it, at an exclamation point and parenthesis, that's going to save your password. And the reality is modern password cracking will eat through that in minutes to seconds in most cases. So length dramatically increases the math, right? If you go from an 8-character password to a 12-character password, or 14 or 16, when you talk about brute forcing that character space, it goes from minutes to hundreds of years to thousands of years to millions of years, depending on how long you go. Long passphrases that are sentences are better, and better yet, encourage people to use a password manager, a secure encrypted store of passwords. So they can generate one very long, very secure, and unbrute forceable passphrase for the password manager, and then everything else can simply be 20-character completely random passwords generated by the manager and autofilled. So like my passwords, I don't know any of my passwords other than my password manager and encryption passphrases. Everything else is random and stored in my password manager. And that makes life a lot easier for the users because A, you get autofill, and B, you get a lot more security. So it makes your life better online. Now, phishing and social engineering, this affects all classes of wallets. And unfortunately, this is the absolute hardest to protect your users from. Fake investment scams, right? Somebody contacts you, somebody sees that you're into cryptocurrency and contacts you out of the blue on LinkedIn or Instagram. I'm, Jane Forex trader, right? If you invest $1,000 with me, I'll make you $9,000 in a week. These are real and they really do get people. It's the fake giveaway scams, right? Send me cryptocurrency and I'll double it and send it back to you. The ledger data breach related scams, extortion, fake software updates, like ledger users being targeted specifically because of the Shopify leak. It's kind of easy as technical people with a lot of know-how to say, well, social engineering, if you send your Bitcoin off to some stranger saying that they can make you $1,000, that's your own fault. That's kind of, idiotic of you. And I think it's really important to have a lot more empathy for people that are victims of these scams. The reality is social engineers are professional predators. They prey on our humanity, they prey on our greed and our weakness. And people that have fallen for these scams come from all walks of life with all levels of know-how. And so, don't just assume that if your users are smart enough to interact with cryptocurrency, that they're also smart enough to not get scammed by one of these supposedly obvious issues, right? This is something that people make their livings stealing from other people using these techniques. And, especially as penetration testers and security professionals, I think you all know how powerful social engineering is. And so the only way to prevent social engineering being a route for stealing from people is education. We have to really train our users on social engineering. I think that social engineering related information should be built into cryptocurrency applications. So, with applications that interact with addresses, maybe, do things like search for a known database of scam addresses and give your user a little warning, right? Of course, we don't want to be in the cryptocurrency space in the business of censoring transactions. People should always be allowed to send money to any address they want to anywhere in the world. That is a critical core component of cryptocurrencies and their censorship resistance and their global nature. But, presenting a little warning to your users about social engineering threats, maybe when they load up their wallet, and then they can dismiss that. Those things can't hurt, right? It's important for people to know about these attacks. So let's end with the good stuff. Bullet points that you can give to your users. Encourage hardware wallets for high-value accounts. I think this has kind of become the gold standard in the industry. Make sure that if you are storing your life savings, you're using a dedicated offline hardware device. Encourage mobile wallets for spending money. So if you have spending money amounts, you want to keep your pocket change in there, be able to send, to introduce new people to crypto, pay your phone bill, buy a book, buy electronics gear online. Again, things I like to do with my crypto, right? Use mobile wallets because they're generally a little more locked down and present less attack vectors than maybe a desktop wallet would. They're not foolproof, which is why I wouldn't recommend keeping your life savings on one, but they're pretty useful for day-to-day introduction to crypto and spending money. Encourage and require strong passphrases, length over complexity for wallets and exchanges. Don't enforce a password policy for your web wallet or your exchange that means the user is going to end up with a short and less memorable password with a bunch of numbers and symbols in it, right? Encourage longer passphrases instead. Encourage a minimum of 12 or 14 or even 16 characters. I like to go with 20. I think 20 is even an ideal starting point for password security. This encourages people to use password managers. Encourage or require strong app or hardware-based two-factor authentication. Again, use modern standards like TOTP for auth apps, or use the U2F or FIDO for hardware keys like YubiKey. I know it's maybe a little bit more engineering work, but yeah, I personally, I always love when I go to a website and they allow me to use a YubiKey as two-factor auth. That makes me feel more comfortable that they are taking my security seriously and they are enabling me to take my own security seriously. Train your users on social engineering. Again, this is no easy task, but in some creative way, I think it's important to make your clients and your users of your applications that you build aware of social engineering techniques that are common and pervasive in the crypto space. Make sure they have a heads up about the type of scams that are out there, and it can prevent them from being stolen from by their own mistake. The security landscape is ever evolving. So of course, I'm a software engineer and a tech educator by trade, not necessarily like a security pro like many of you in the audience. So, this is not meant to be a comprehensive list or extreme security expertise. This is about, some of the broad classes of security topics, threats, and best security practices that are currently being worked on in the industry. Always be open to new information and feedback. I like to learn something new every day. And I think that it's important for us as security and software and education and marketing or whatever you're doing in the cryptocurrency space to always be learning, because this is a young and very rapidly growing space. With great power, being your own bank, comes a great responsibility to take your security rather, and the security of your users seriously. So overall, train your users to think about security first. Whatever you're doing with your app, your testing, your promotion of a particular project, always throw in a note about security. A simple note, simple bits and pieces about security best practices can save your users from headache and harm. And develop your software with security first mindset. It is fun when you engineer software, and especially if you're making things that are just educational, to go fast and break things. But especially if you're developing production software that is really meant for people to use with serious money, always have security in the forefront of your mind. Security is critical in this space where leaking a private key could mean somebody loses their life savings. So take it seriously. Make sure your users take it seriously. And it's always great to learn something new about this. So thank you all very, very much for having me today. And I'm going to open up the YouTube stream here and mute it so I don't get echo, and I can take some questions if we have a couple minutes, of course. Any questions in the chat?
Hey, Josh.
Yes.
Okay, so I think there are no questions. There's a comment from Nathan. He's saying, love your work. I'll definitely be looking through your resources on your website and sharing it wherever I can. Thanks again for the presentation.
Yeah, thank you all so much for having me. My main website is chaintuts.com. I have a contact form on there. All my social media is on there, and I'm mainly on Twitter at ChainTuts. So please feel free to reach out if you have any questions. My slides and this video will be on the website and my YouTube channel as well. Thanks again, team, for having me. This was great.
Thanks, Josh. Same here for us, and thank you for sharing your knowledge with us. It was a wonderful pleasure for us to host you in our Unchained Blockchain Security Conference. And yep, that's all for the session. And we'll see you soon in the next event.
Take care, everyone. Enjoy the break.
Yep. See ya. Bye-bye, Josh.